Okay, now let's talk some more about arcs and arc measure. So here we've got another circle, and we're saying that the measure of a minor arc is equal to the measure of, and we hinted at this before, of its corresponding central angle. So let's get a center point here, and let's draw a couple radii, plural for radius. And let's say this is R, this is S, this is T, and let's say that this central angle right here is 50 degrees. Now, what would be the measure? What would be the measure of arc RT out here? Now we want a degree measure. So, as we said earlier, the measure of an arc is basically the measure of its corresponding central angle. So here, the measure of arc RT is going to be, well, it's just going to be the same as the measure of angle RST, which is 50 degrees. So there you go. That's the measure of arc RT, is 50 degrees. Now let's say we want to look at a major arc. If we're trying to look at this major arc all the way out here, we need another point to describe it. We need 3 points, so I'm going to call that point Q. So the measure of arc TQR, what do you think? What is that going to be? Well, we know that in a whole circle we've got 360 degrees, right? So if we want to know just this part right here, this major arc, let's do 360, the whole circle, and take away this part, this arc RT. So it's going to be 360 minus 50. That's going to be 310 degrees. So there you go. All right, hopefully that wasn't too bad. Let's jump down here to problem 2, and this is where I would suggest that you pause the video and try to do these 4 parts on your own, see what you get. All right? And did you do it? How'd it go? Not too bad, I hope? All right. So measure of arc BC. Well, let's look over here. BC, that's this part. The central angle, they tell us, is 32 degrees, so that's just going to be 32 degrees, no problem. And now, how about BT? From here to here, well, this is 32 degrees, and they give us this is 58, so let's just add up 32 plus 58. That is 90 degrees. Whoa, right angle, nice. And measure of ABC, that arc, well, you see AC, I think it's pretty clear that AC is a diameter, so then arc ABC is a semicircle. Again, this is going off the fact that segment AC is a diameter. Now, measure of arc just AB. Well, ABC is 180, and then this piece is 32. So we can just do 180 minus 32 equals 148 degrees. Boom, not bad. Okay, now let's jump to the next page. We're going to talk about circumference. Previously, we talked about arcs and their degree measure. Now we're going to talk about circumference. Circumference is a distance, it's a length, not in terms of degrees. So, some pretty common formulas here. Circumference can be talked about in terms of diameter. So we can do pi times d, where d is the diameter. Or we can say circumference is 2 pi r. Okay? So again, we're talking about going all the way around the circle. If you had to walk the length of this circle, how far would you walk? I mean, the degree measure is 360 all the way around, right? 360 degrees. But circumference talks about actual length. So it's circumference equals pi times diameter, or 2 pi times the radius. And the reason you can say either of these is because the diameter is equal to 2 times the radius. Now let's take a look at this problem down here. We've got this gentleman, I think he's maybe a director or a movie actor. So we've got this circular track, and the track itself is 2 feet wide, as you see right there. And it's a circular track for a camera dolly for this movie scene. Clearly he's an actor. Look at the fancy jacket and tie. And I think he's got some glasses and a mustache. Of course he's an actor. And then the 2 rails of the track, they form concentric circles. That means there's 2 circles and they have the same center. Concentric, with the same center. Okay, the radius of the inner circle is 8 feet. So, how much farther does a wheel on the outer rail travel than a wheel on the inner rail? So it's basically this wheel right here. How far is this one traveling versus, say, this one all the way out here? So if you want to pause and come back, do it. All right. So this is basically a circumference question, right? So let's look at the 2 circles. First, the inner circle. The circumference, again, we're dealing with, we're given a radius, so let's go with 2 pi r. So here it's 2 pi for the inner circle, the radius is 8. So we've got a circumference of 16 pi. How about the outer circle? So the outer circle, the radius there is, well, it's the 8 plus the 2, so it's 10. So circumference here is going to be 2 pi times 10, or in other words, 20 pi. Now, go back to what they were asking for. Oops, let me scoot up. They're asking for, what are they asking for? How much farther does a wheel on the outer rail travel? So, how much farther? We're talking about difference. So let's do a difference of 20 pi minus 16 pi. These are both in terms of pi, so we can leave it in terms of pi. That's 4 pi. And if you wanted to do a little calculator business, that's approximately 12.57-ish. Just depends on how they want you to give the answer. All right, I'll come back with one more video after this.